We are now at 10.3, day 3. Really, we've been doing this a lot more than 3 days for the unit circle, and it may be starting to get quite tedious. I'm sorry to say, it's still going to be tedious because I'm trying to kind of beat this in your brain, and we're going to practice until we are just flying through the problems and super confident with everything that we're doing. So I'm going to model 1 through 6 with you, and you'll end up trying 7, 8, and 9 all by yourself. So I'll move at a quick pace since all of this should be review. Number 1, we are going to sketch the angle, find the reference angle, and if it's on the x-axis, just write quadrantal angle. Really, the reference angle is 90 degrees because that's how far away the terminal side is from the x-axis. But like I said, we'll just write quadrantal angle if that happens. So for number 1, my angle here is 0, 90, 180, 270, 360. But I'm just going to stop there because I know that 150 is between 0 and 90. In fact, 150 is going to be right about here. Remember, for standard position, we have our initial side here. Don't forget to draw that, and our terminal side, showing where the 150 will fall. Just by looking at this, I can tell what the reference angle is. If this is 150, see how there's a difference of 30 between 150 and 180? So at this point, I would say if this is my theta, and this right here is my theta prime is 30 degrees. But of course, you could use the rules. So in quadrant 2, theta prime is equal to 180 minus theta. That's 180 minus 150, or that is 30 degrees. So that's, again, completely up to you. Do whatever you want. Number 2 is 210 degrees. So here's 0, 90, 180, 270. I know that 210 is in between 180 and 270, so it's going to fall in quadrant 3. 210 is right about here. So this is my theta. Connecting my terminal side to my x-axis is theta prime. Again, just by looking at this, I can see that the difference between 210 and 180 is just 30 degrees. So I could just write 30, or I could use the rules. Remember, if the theta is between 0 and 360, or 0 and 2 pi, we just use these rules. Quadrant 3 is theta minus 180. So 210 minus 180, hey, looky there, that's 30 degrees, like we said. Number 3 is 540. We could draw the angle with multiple rotations, no big deal. But when we're doing reference angles, we really would like theta to be between 0 and 360. So I'm going to find a positive coterminal angle by subtracting 360 until I get to that range. If I subtract 360, that gives me 180. Which is between 0 and 360, 0, 90, 180. It looks like I have a quadrantal angle. So that's all I'm going to put. For number 4, it does say sketch the angle, but just by looking at this, I already know that theta prime is pi over 4. Really quickly, if I wanted to draw this, I know that it's 0, pi over 2, pi, 3 pi over 2, 2 pi, or 0. I know that pi is 4 pi over 4, 2 pi is 8 pi over 4. I like to do these first because it makes the other ones easier. Halfway between 0 and 4 is 2. Halfway between 4 and 8 is 6. So 7 pi over 4 is between 6 and 8. So I start here. Rotate. There we go. Pi over 4, by the way, is 45 degrees. So I know that the legs would be root 2 over 2, root 2 over 2 if I had to deal with that. But this right here is my theta prime. Number 5, likewise, just by looking at it, I know theta prime is pi over 3. If I wanted to actually draw it, I could find a positive coterminal angle by adding 2 pi, which would be negative 2 pi over 3 plus 6 pi over 3, which would give me 4 pi over 3. So you could go that route, or you could just do your negative angles. So this is 0 and go in a clockwise rotation. This is negative pi over 3, and this is negative 6 pi over 3. Halfway between 0 and negative 3 is negative 1.5. So negative 2 pi would be right about here. That's up to you. I don't know. It just kind of depends on how you want to approach it. But there's my theta prime right there. Remember, you're always connecting your terminal side to your nearest x-axis, and there's a distance of pi over 3, which is 60 degrees, which would be helpful knowing that if you were asked to actually evaluate it. Number 6, we have 5 pi over 2. I'm going to go ahead and find a coterminal angle just for practice. So I'm going to subtract 2 pi to get me between 0 and 2 pi, which is 4 pi over 2, and that just gives me pi over 2. The reason why I did this is because I already know where pi over 2 is. It's right here. So that's a quadrantal angle. If you wanted to draw the whole thing, that's one full rotation, and then it goes an additional pi over 2. But that's up to your discretion. I'd like you to go ahead and try 7, 8, and 9. When you're done, hit play and check your work. Number 7, your theta was 60, which is in quadrant 1, so theta prime is also 60. Number 8, 0 degrees, that's a quadrantal angle, so that's all you had to do there. And 7 pi over 6 was right here, so that's what your theta should look like. Theta prime is 7 pi over 6, or that's also equivalent to 30 degrees. For 10 through 15, you're going to find the exact values of sine, cosine, and tangent. So I would first is sketch the angle for 10, 11, and 12. I already did that. So I'm going to draw my special right triangle. If theta is negative 60, I hope you can see that theta prime is 60 degrees. So I have 1/2 and negative root 3 over 2 here. If I wanted to evaluate sine of negative 60, cosine of negative 60, and tangent of negative 60, sine is the y value, cosine is the x value, and tangent is y over x. So sine is negative root 3 over 2, cosine is 1/2, and tangent is negative root 3 over 2 over 1/2. And then you just do keep, change, flip. You get negative root 3. I'll do number 13 with you. You could go ahead and draw 270. I like doing coterminal angles between 0 and 360. So I'm just going to add 360 to find a positive coterminal angle. And if I add 360, I end up with 120 degrees. So that's really easy for me to go ahead and draw. 120 is right here. So I can see, oops, that this is my theta prime, which is 60 degrees. And that's really easy for me to go ahead and plug in those values. But because it's quadrant 2, my x is negative, my y is positive. So if I want sine of negative 240, it's the y value, or positive root 3 over 2. If I want cosine of negative 240, it's the x value, or negative 1/2. And if I want tangent of negative 240, it's y over x, or root 3 over 2 over negative 1/2. Then you just do keep, change, flip. And that gives me a negative root 3. Oops. Sorry about that. I scooched it up so you can see it now. Go ahead and pause the video, try 11, 12, 14, 15, and hit play when you're ready to check. Go ahead and pause the video, check all of your work. Hopefully it went okay, and this is starting to get really boring because you know how to do it, and I'm making you repeat it nonstop. So everything on this side of the notes is the exact same thing as you were just doing. It's just now instead of degrees, it's radians. So same process. We're going to draw the angle, find the reference angle, label the sides, evaluate the trig functions. I'll do a few of these with you. Number 16 wants you to draw pi over 6. You should know quadrant 1 already, and you should recognize pi over 6 is right there without having to do much. Pi over 6, keep in mind, is equivalent to 30 degrees. So I know that this is 1/2 and this is root 3 over 2. So if I want sine of pi over 6, it's the y value, or 1/2. If I want cosine of pi over 6, that's the x value, or root 3 over 2. If I want tangent of pi over 6, that's y over x, so 1/2 over root 3 over 2. Keep, change, flip. 1 over root 3 is a big no-no. We got to rationalize, and I get root 3 over 3. And number 17 is also in quadrant 1, so I'm not going to do that one. Let's do number 19. Number 19 is a negative pi over 4, so that's right here. That's just because I know negative goes this direction. Super simple. Reference angle you should be able to tell is pi over 4, which is 45 degrees. That's root 2 over 2 positive x value, root 2 over 2 negative y value. So that would be sine of negative pi over 4 is negative root 2 over 2. Cosine of negative pi over 4 is a positive root 2 over 2, and tangent of negative pi over 4 is going to be negative root 2 over 2 divided by root 2 over 2 because it's y over x, and I get negative 1. And 22. 22 is right here. I'll go ahead and draw it. So this is 0. Pi over 2, which is 2 pi over 4. This is 4 pi over 4, 6 pi over 4, 8 pi over 4. So 5 pi over 4 is right here, meaning that my reference angle is pi over 4, or 45 degrees, and then we would go ahead and just write the values. Keep in mind what quadrant it's in, and you'd find sine, cosine, and tangent. So sine would be negative root 2 over 2, cosine would be negative root 2 over 2, tangent would be negative root 2 over negative root 2, which is just a positive 1. So that should be pretty straightforward. I do want to do one more with you, and that's 21. 21 is a little bit different because negative pi over 2 is right here. It's a quadrantal angle, so I just want to show you, if you have a quadrantal angle, just use your coordinates. This is 0, negative 1. So it should be pretty straightforward. We already have the x and y values. Sine of negative pi over 2 is the y value, so that's negative 1. Cosine of negative pi over 2 is the x value, so that's going to be 0. And tangent of negative pi over 2 is y over x, so that's negative 1 over 0. But that's a no-no, so it's undefined. If it would have been 0 over negative 1, that would have been okay, and it would have been 0. But that's not what happened, so that would be our final answer. Try the other problems, hit play when you want to check. So pause the video and check 17 and 18, hit play when you're ready. Pause the video and check 20, hit play when you're ready. And pause the video to check 23 and 24, and we are all done. So good luck on your homework, and yes, it will be repetitive. I'm sorry, but I hope your skills are strong by now.